what is today's topic? We are carrying on with trig identities. And the important things that we did in the last lesson were that sine squared x plus cos squared x equals 1. And then that could be rewritten as, if I wanted to, I could rewrite it as sine squared x equals 1 minus cos squared x, or we could do it cos squared x equals 1 minus sine squared x. So that's the same identity. It's called the square identity, but you can rewrite it in different ways. And so while we're doing today, we always have to keep an eye out for these patterns where we can substitute different values for things. And then the other one that we learned about a lot in the previous lesson was the tan of x is the same as the sine of x over the cos of x. Or if they say to you tan squared x equals, then you can rewrite that as sine squared x over cos squared x. Give me a thumbs up if those all look familiar to you. I'm not saying you're a ninja at handling them yet, but at least you've seen them, and they don't frighten you. You're like, yeah, these are my new friends. I'm going to learn how to interact with them. Let me see those thumbs on the, I want to see some emojis or emoticons or whatever they're called. Fantastic. Oh, welcome to Danielle. All right, and then in addition to these identities, which are the main focus, we also have some of the reduction formula identities that crop up from time to time. So, for example, if I said to you, what is the sine of 180 plus x? That is equivalent to minus sine x, and you can look at our previous videos on the reduction formula for that. Or if I said to you, what is the cos of 180 minus x? That would be the same as minus cos x. So those are often called the reduction formula. And then we also have co-ratios, which would be something like the sine of 90 minus x. And when we use the vertical axis, so the 90 is a vertical axis, not a horizontal axis, that goes to cos x. Let me put that in a different color. So give me a thumbs up if you recognize that from earlier lessons. If you weren't at the earlier lessons, you may have to go back and look at these again. But these are kind of our tools for today that we're going to play with as we begin our lesson. So let me see the fingers fly. Okay, so now some extra tricks for today. When we are dealing with more difficult identity questions, you sometimes have to replace one with something. So you've got a one and it's not very helpful. So common tricks that are used are, you can write one as cos squared x over cos squared x. You can write one as cos x over cos x. You can rewrite one as sine x over sine x, or you can rewrite it as sine squared x. Now, or you can even write it like this. And you may say, what is this crazy person doing? But I'm just trying to show you that you can take a number and change it into a trig ratio sometimes. And so that can be a useful trick if you want to transform a number. In fact, you can actually write any number like this, because all you need to do is, if I have the number 2, right, 2 times 1, well, that would just be the same as 2 times this, or 2 times this, because that's 1, 2 times this. So if you ever have to change numbers into trig ratios, this is a very common trick. And I don't think many students know about this. So again, give me a, what's going to be the, give me a 10 if you understand. Put a 10 in the chat if you understand this little identity or equivalence trick. I want you to put the number 10 in the chat if that little trick makes sense to you. Okay, awesome. Then another way that this trick might be used is if I have, let's say I have cos, let's say I have 1 over cos x plus 1. And I want to put these two together. What do you think I should do to the 1 in order to add these two things together? So I want to knit them together, but I feel stuck because I've got a 1 and I want to put them together. How can I put them together? What should I do? I'd love someone to put their hand up or give me an idea of where they would go. What should I do? What should I replace the 1 with if I want to add these two things together? Put your hand up. I respect you so much just for sharing your thinking. It doesn't have to be right, but just by sharing your thinking with your classmates, everyone benefits. It's like community service. Think of it that way. Who wants to have a crack at this? What would you replace the 1 with if the goal was to put these two together? I can sense that Pila is feeling like it's me, pick me. Pila, what do you think? What should I do? Sam? Ah, yes. Okay, Bukle. So what you can do is you rewrite this where the 1 is a cos x over a cos x. And why is that so helpful? Well, if you want to add two fractions together, you always have to have the same denominator. And so what this means is you can write down the denominator, and on the top, you do that. And so that's also a common trick in that in harder identities, remember last time we did the slightly easier ones, in harder ones, you sometimes have to join things together. And so that's another trick I want you to watch out for. Give me a happy face or a thumbs up if you understand that little trick. I want to see some feedback from the people of the room. Okay, I think we are now ready to engage with these slightly harder proving questions. Okay, so if we think of this as an exam question, what it would normally say is, I've kind of taken the word out, but it would say, prove this is true. And what we have is we have two sides here. We have the left-hand side, which I'll say is the green side, and the right-hand side. The normal technique with these is to work with the more difficult side and make it equivalent to the right-hand side. So what I'm going to do is I'm going to pull out, I'm going to say to my marker, I'm working with the left-hand side. And the left-hand side is that. Okay, now I have to go on a journey. What should I do? Thinking back to the last lesson, what should I do in order to start my journey if my journey is trying to eventually get me to this thing, which is the right-hand side? Where would you start in question 1? Where would you start in question 1? I need some tips from the room. Yes, I think that the tan x could be replaced. So I want you guys to replace the tan x, and I want you to see how far you can get. Once you are stuck, I want you to say stuck in the chat. If you're done, I want you to say done in the chat. But I want to see if you can take what I've given you so far today, and I want to see if you can use it to help you navigate the next 2 steps. And I want to give you some time for that. Either you say stuck when you're stuck, or you say done when you're done. So over to you guys. Hmm. Okay. So I was thinking we do that, but now I'm still a little bit stuck because I need to write that as something over 1. So I get sine squared x over cos x, but the problem is I've got this, um, I've got this, now, okay, now I'm clearly not there yet. I remember where I'm going to. I'm trying to get to 1 over cos x. Okay, here is the sneaky bit. Now, the problem I have is that these denominators are not the same, but there is something I can do to make this denominator what I want to do be, but I also need to then do something to the top. So I'm going to indicate that by a block. And the reason is the block is the same, so it doesn't change anything. What do you think is going to go in the blue block? Bukle, let's go to you. What do you think goes in the blue block?
So I was also thinking, because in the blue block, it's going to be cos x on both the denominator and the numerator. But then also we want to change the sine squared x.
Okay, before we even do that, let's just, because I think you've already given us a very helpful tip. So if we go here, what you're going to get on top, would you agree, Bukle, you get cos squared x?
Yes, sir.
Okay,
Over
now the
cos.
good news is we have forced the denominators to be the same. So by timesing this in, we now have the same denominator. And because the denominator is the same, we can then add them and we get, and this is what I think you were getting to. Do you recognize something about the numerator, Bukle?
It's an identity. And sine squared x
What?
plus cos squared x is equal to 1.
Exactly. So this thing over here is going to be the same as 1. And that's fantastic news because it's 1 over cos x, which is the same as the right-hand side. And so we've proved it. So let's go back for a second and look at the key steps that happened. Step 1 was to replace the tan x with sine x over cos x. Then we multiplied out and we got a bit stuck. And then the really important next step was this idea that I wanted to force the denominators to be the same so I could put them together. The reason I wanted to put them together was I knew that where I was heading, there was only one fraction. And then I spotted, once I put them together, I spotted that there was another identity in there. So give me a score out of 10. If 10 is perfect understanding, 0 is no understanding, how do you feel about that question 1 now? That was a harder one. Like, that was a harder question. I don't expect you to get that right now, but I want to see how you feel about your understanding, and that will help me decide on the next example. Okay, no, that's good. So we have some understanding, but we need to practice and keep going with this. Okie dokie. So let's have a look. Do we want to do that one, or do I want to do that one, or do I want to do that one? Okay, let's try for number 4. Let's do number 4. So, of the two sides, which side do you think I should start with? So the question is, let's set this up. We need to prove that that side is equal to that. Which one should we start with? The left-hand side or the right-hand side? Put your answer in the chat. Where would you start? And there's more than one way to do this, but I have a preference which I'll reveal in a moment. Okay, here's the thing. I think it is easier to stick things together. So if I want to put these together, and I don't know how to do it yet, but I think it's easier to stick those two together than it is to break these two apart. So for me, I think I would try and work with the left-hand side and then use whatever techniques I can to make it look like the right-hand side. So for me, I would start with the left-hand side. And solving trig identity questions is a little bit like being a detective. You need to change this so that it eventually looks like this. But the problem is you only have tans at this stage and you need sines. And also, this is only one fraction together. And this is two separate things. So let's ask the class, where would you start? But let me use a different color because I think the red's not the best color. Contrast isn't great. So let's start with this. Where would you start on your journey to prove that these two, the left-hand side is eventually equal to the right-hand side? Who has some ideas? Where would they start with replacing things? Or what would they replace, I guess? I would replace the tan x. Yeah. So, I mean, if I replace the tan x, I'm going to get 1 over sine x over cos x. And over here, I'm going to get sine x over cos x. Now, that's not too hard to do, but what I am a little bit worried about is dividing by a fraction looks a bit messy. Does somebody have something I could use that would help me clean this up a little bit? I want to clean this up. And there's an idea that we use, like in let's say grade 9 maybe, or grade 10, where if we have like 2 divided by a third, we can rewrite that as 2 times 3 over 1. It's called Toppin times. And I think we can rewrite this in a way that helps us here. This will be easier to do with an audio prompt. Who feels like they can help us with this? What's it going to look like? I'm going to get 1 times by what? And then I'm going to have my plus sine x over cos x just hanging out down here. What am I going to times it by here? So it's going to be, I've got to flip it over because you're timesing now. And so the cos x is going to be on the top and the sine x is going to be on the bottom. So that's a little bit weird. Okay. But it's this Toppin times idea. Like if you think about this, if you go 2 divided by a third, it's the same as saying 2 times 3 over 1. Give me a thumbs down if you don't understand this idea, the Toppin times thing. Give me a thumbs up if you understand the Toppin times idea. Let's see what the people of the room think. Do you understand the Toppin times idea? And then if I think about this, look at our sine x over cos x. Now this bit is, yeah. I'm not seeing anything in the chat. Am I missing something? Or am I seeing thumbs up, thumbs down? Okay. There's a bit of a mixture. So basically, if you're dividing by a fraction, if you change it from division to multiplication, you just flip the fraction over and then you're good to go. So what I did was, this used to be division. So this thing over here used to be division. Now it's multiplication. And you'll notice that it's not sine x over cos x, it's cos x over sine x. Okay, let's get this one done. So then what I have is cos x over sine x plus sine x over cos x. Oh my goodness, have I made life even worse for us here? What is going on? Okay, now here's the thing. I can't stick them together yet. And the reason I can't stick them together is that they have different denominators. Because this is a sine x and this is a cos x. But you know what? There is a sneaky trick for this one too. I'm going to times, well, let's times where should I put the times? I'll put it in front. There's going to be a red block, and I'm going to times the top and bottom by something in the red block. And then I'm also going to times the top and bottom here by something in the black block. I want to know, what do you think goes in the red block? What do you think I'm going to put in the black block if my goal is to put these two things together? What do we think is going to go in the red block? What do we think? So the red, exactly. The red has to be cos x. And the reason it has to be cos x is we're trying to build the same denominator. Let me just turn this mistake. So maybe I should even zoom in because it's a little bit small. So let's go. We're timesing this by cos x, and we're timesing this by cos x, and that's good news because it's not going to change the overall fraction. And here we are timesing by sine x. So that's sine x. And now what we get is what's cos x times cos x? It's cos squared x. And what's going to be on the bottom? It's just cos x times sine x. And then over here, it's going to be plus sine squared x over cos x sine x. And then what we're going to notice is I'm going to rearrange the top. So I'm going to put it on the bottom. I'm going to make this sine x times cos x because I can write the order. And then I'm going to write this as sine squared x plus cos squared x. Now, let's see where am I ending up here? Goodness gracious. This is taking a life of its own. Okay. What do you think is going to go in this box over here? I know what's going to go here, but okay, so we make it 1. Sorry, guys, this ends up being quite a nasty one. But anyway, that ends up being 1. Okay, now, here's the thing. Where are we trying to get to? We're trying to get a tan x. Okay, now, how can I get a tan x? We're almost there. I actually need to replace what I'm going to do. If you look at where I'm going, this is a bit of a toughie. I'm going to replace, I'm going to times the top and bottom by something. What do you think I'm going to times the top and bottom by now? Bearing in mind, I think we're going to times the top and bottom by sine x. And then we are going to get on the top sine x, and on the bottom we are going to get sine squared x times cos x. Okay, what a mouthful. Now, we're almost there. Do not despair. What is sine x over cos x the same as? What is sine x over cos x the same as? It's tan x, yes. So that's tan x. And on the bottom, I have sine squared x. Oh my gosh. Okay, I think I chose the hardest identity in the history of the world for you guys today for this one. Sorry. But it turns out that that's the correct answer. So let's just do a little recap. And what I want to say is that this is about the hardest of the hard questions. So if you're feeling a bit overwhelmed, I don't want you to stress out. But let's just go on a repeat journey from the beginning. Now, there probably was another way of doing this. Maybe I could have done it in an easier way, but at least it gives us an experience of what's going on. So step one was substituting the tan x for sine x over cos x. Step two was using the tip and times. So we tip and times it. Step three was making a denominator that was the same and putting it together. Step four was realizing that this thing over here was 1. And then the last step was multiplying by the sine x on the top and on the bottom in order to get it into the format that I wanted, and then recognizing this. So honestly, this was about an 8 or 9 mark question. But yeah, I hope I haven't frightened you to death. Who feels, give me a score out of 10, and I know that was a hard one, but give me a score out of 10 about how you followed my explanation. Because if you could get this one, this is a toughie. But you can re-watch this again after class. Okay. Now, for those, especially if you missed the beginning of the lesson, you might have found that some of the tricks I was using there, you needed to watch the beginning, but don't stress, you can always watch the recording after that. Okay. After that mind-numbing question, it's time for some exercise, compulsory exercise. I want to see everybody's screens on, and I want to see you join me in a bit of brain exercise so that you can pick up the pieces after that rather challenging one. Okay, let's start with some deep breaths. Then one more nice deep breath. Okay, then we need to loosen up our bodies now. Probably got a bit tense after that last question, so we shake out our arms, shake out this arm, shake out this leg, shake out the other leg. Then let us do some sort of circles like this with our shoulders going forward, and then circles going back. Then let's put our arms out and just twist like this. And start slowly and just keep twisting. Okay, then let us do some jumping jacks. So the main purpose of the jumping jacks is your heart rate gets so high, like your brain just can't think about anything else, which is kind of what you want. You want your brain to just relax. Okay, let's do 15 in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, and that is it. Okay, and then let's just do a little puzzle just to let the brain unwind a bit further. So, can you make 24 using these 4 blue numbers? See what you can do. Who can give me an answer for this? Okay. Who feels like they can do this? So, Nomfundo on fire. 8 times 2 is 16. And then 7 plus 1 is 8. And then 16 plus 8 is 24. Very nicely done, Nomfundo. Very nicely done. Okay, let us go back to another question from the Trig identity land. And let's see what we can do with number 2. Now, these are the meaty ones. I'm not going to lie to you. Although, you know, we could do actually. Well, let's see how this one goes. Let's see how it goes. Okay. We're going to do them as a team. What should I start with? What should I start with for number 2? Which side? There's always going to be a choice between 2 sides. You need to decide which side we start with. I will follow your lead. Yeah, so I think it's pretty clear the left-hand side is the harder side to deal with. And so we're going to start with the left-hand side like that. Now, I don't think I can do much to the sine x. The only thing, give me a thumbs up if you agree that tan x is the only thing that you can really change at this point. There's nothing else. There's no other. Clearly, you have to do some conversions and things like that. But like, it's too early to be multiplying these together. So we have to go sine x over cos x. And then this stuff over here, well, there's not much I can do to it right now. And a lot of this is just exploring. Okay, now we have another decision to make. Where would you guys go next? Where do you think you would go next if you were dealing with this question? It's sort of like, like mystery, like you're like solving a mystery and you have to kind of go with some clues. Then also you have to take some chances and just investigate. Well, the 1 plus cos x, you could, but I was thinking, what about if we wanted to stick these two together? What if I wanted to stick this stuff together? Would there be a way of sticking these two together? So, yeah, I think you have to get the denominator the same. And what I'm going to do is I'm going to say, look, this is actually over 1, because that's a handy trick. And then I'm going to multiply the top by something and the bottom by something. And you know what that something is going to be? I think that something is going to be a cos x. Wouldn't it be a cos x? Because, like, if I want to add these two fractions together, then surely I have to make it the same. So, like, I'm going to say, look, this is going to be times cos x, and this is going to be times cos x. Now, again, I'm just going on a hunch at this stage, but it makes sense. So what we then have is, why don't you write what's in the bracket? What are you going to have in this bracket over here now? So take a moment and then say done. When you've written what you think I'm going to write in this bracket, I want you to go done. And then on this side, this is just staying like this. So say done when you've written what you think I'm going to write over here. Okay, so I know that I'm going to have a cos x. And then, do you know what? To make things a little bit neater, I'm going to write it as, well, actually, not even, maybe I should just write it as, I'm going to write it as, I can just leave it like it is. What I don't need to do. So cos x times sine x plus sine x. So here is something interesting. I need to zone in on this thing over here. This is the part that is interesting, and I need a new mathematical technique that is going to allow me to probably cancel something out. Who has an idea about what I can do with the green stuff there? I've put it together, so I've got one fraction, but it doesn't seem like I can cancel anything out at this stage. There's no common factors at the top or the bottom yet. What technique do you have for rewriting something from earlier on in algebra and things like that? Not add them together, but you're on the right track. So Naledi has spotted that there's a sine x here and a sine x there. Does anybody have an idea of what technique you could use to maybe make some different factors here? So I was thinking, have you heard of the thing called highest common factor? If I said to you, I'm going to take out sine x, I want you to tell me what is inside that bracket. The cos x on the bottom is going to stay the same. The blue stuff over here is going to stay the same. But I want you to tell me what goes inside this bracket over here. Pop it in the chat. What do you think is going to go in here? Okay, I'm going to help you. I think there would be a cos x. And the reason is there's the cos x. And then there would be a plus 1. Now, this is good news because I have spotted something. Can you see that cos x plus 1 is exactly the same as 1 plus cos x? So what do you think we're going to do with those two factors that are exactly the same? What do you think we're going to do with those two factors that were exactly the same? Who has some ideas? Anything over itself is actually the same as 1, and so we are going to cancel them out. Yes. All right, now here we are almost there, ladies and gentlemen. Now we have sine x times sine x over cos x. What do you think my final step is going to be to solve this trig identity? So I think I've spotted that this sine x over cos x is the same as tan x. And so this will become sine x times tan x, which awesomely for us is the right-hand side. Now, again, let's go back and look at what we did. Step 1 was to replace the tan x with sine x over cos x. Step 2 was to make the denominator the same and put it together. Okay, so that was that. Step 3 was to factorize. Step 4 was to cancel out. And step 5 was to recognize the identity with tan. Again, another tough question. Now, this is probably the hardest questions I've done in the whole unit. Out of the 8 lessons I've done now, these are the top of the mountaintop. But it's nice to know that even if you don't get them perfectly, you can understand the thinking that is going into them. So again, give me a score out of 10 as to how you're feeling about this, my explanation here. 10 is perfect, 5 is some, 0 is nothing. Tell me how you're feeling about These, I know these are hard, but I just want to see how much you grasp from my explanation. Okay. Cool. Because remember, I can't see your body language, so you need to be honest, brutally honest. Okay. Cool. Now, the last question we're going to do for today is not going to be like this one. We're going to go back to what's called a, oh, where did I put that? Here we go. Okay. Now, this is a slightly different type of question. Instead of using the identities for like sine squared plus cos squared equals 1 and stuff, these are reduction formula and co-ratios. And so what I want to do is I want you to have a go at solving number 2. So can you try and simplify? There's no left-hand side and right-hand side. This is just a simplification question. And see if you can do number 2 using your knowledge of these things. So over to you guys. I want you to try and work with that and then raise your hand if you have a question or a comment. And then after we're done with this one, I'm going to give you the link to the quiz for the week. So I'm actually going to grab it in the meantime. So when you do this one, you really are breaking it up into lots of little questions. So can you do that one? Can you do that one? Can you do that one? And what you want to think about is you want to think about a cost diagram. And why don't we do this? Tell me first, what do you get for the green one if you're reducing it? So what does the sine of minus theta become? It's in the 4th quadrant because negative angles go in that direction. So what does the green box reduce to? It's just going to be minus sine theta because in that quadrant, sine is negative. And how far away is it from the nearest horizontal? It's just theta. Okay, but now what about the blue one? What is going to go in the blue one? Where is 360 plus theta? So if I start here, that's 360, that's plus theta. So it's in quadrant number 1. What is that going to simplify this thing to? Remember, there's a horizontal at 360. So this one is going to break down to positive, because everything is positive in this quadrant, plus cos theta. Okay, theta minus 90. This is a bit of a sneaky one. This is going to be a co-ratio question where you have to reduce. Now, where is minus 90? Minus 90 is over here. And so what quadrant is this going to be? Theta minus 90 or minus 90 plus theta? It's going to be in this quadrant. So is cos positive or negative in this quadrant? It's positive. But since you are going from the nearest vertical, this is going to become, and we might run out of time for today, but this is going to become plus sine theta. And then cos of 180 plus theta, that is in quadrant 3. And so that's going to become minus cos theta. So if I want to rewrite this, what I need to do now is I need to multiply this out. So minus sine theta times this is minus sine squared theta. Minus times a minus is a plus. And then this is going to be plus, what's this going to be? Plus also sine theta, what's going to be sine, yeah, times cos theta. And then what is this? This is going to become minus, so, and it's going to be cos squared theta. All right. So what we are then going to have, okay, this is actually another tricky one, but if I take minus sine squared theta minus cos squared theta, and then I take this bit, there's two of these, so I get 2 sine theta cos theta, and this bit over here, okay, this is, again, I'm going to pull some ninja tricks here. And then, okay, this is actually a grade 12. So this is a grade 12 identity. So I'm not going to stress too much about that. But what do we think? I might have taken that from a grade 12 paper. What do you think the thing in yellow is going to end up being equal to? So this bit over here is going to stay there, but it's basically just going to be minus 1 plus 2 sine theta cos theta. And in matric, you'll learn about that thing a bit further. Okay. Grade 11s, I do feel like today's lesson was a particularly difficult lesson. So if you are feeling a bit like whoosh, remember this was the 8th lesson in trigonometry, but that was a bit of a sneaky, tricky one. So don't stress if you're feeling a bit overwhelmed. You'll see that the quiz we do today, which I'm going to put the link in the chat for, is a lot easier than the level at which we are currently operating because, yeah, we're consolidating our learning. So let's just start with that.